search, depth first search, and depth limited search, and uniform cost search also, and only bidirectional search. Today we will discuss bidirectional search along with all searching techniques of informed search, right? Then let me share the screen with you. I have shared the notes: bidirectional search, best first search, A-star search, algorithm. Okay. Listen, this is the theory of bidirectional search. How actually it works in case of bidirectional search. As its name suggests, bidirectional search means two types of searches will run here. Okay, one is your forward search, another one is your backward search. And forward search will be started from initial state, backward search will be started from goal node. In this case, in case of your bidirectional search, you in all types of searching techniques it will be mentioned, like in case of your other searching techniques that we found till now, that was the tree like structure where you had a root node. From the root node you will start your searching process, and you were given one goal node. In this case also, this type of graph or tree will be given, and where you will be given what is the initial node and which one is your goal node. Okay, let in this case initial node is my 1 and goal node is 16. Okay, as I have told you, this is the bidirectional search. That means two types of search, two searching process will work here. Forward search will be applied from initial state, and backward search will be applied from node. So I will start from 1. If I am applying forward search, listen, you start from your initial node 1 and apply your forward search. Okay, simultaneously from goal node apply your backward search. If in a middle point, if in a node they both of them intersect, then you can say that this searching is successful and this one is my goal node. Okay, if you meet in a node, or you can say that intersecting node, if they intersect each other in a node, then you can say that searching is successful. And the goal node that you have chosen, here I have chosen 16 is my goal node, or it is being asked that 16 is my goal node. That is not the final answer. Here you have to check whether 16 is goal node or not. If you reach in a final, if you reach, or if both of them intersect in a single node, then you can say that yes, 16 can be a goal node. Okay, that is the thing. So you start from your initial state. If as I'm saying this here, for forward search you have to apply. So forward search means you have to go 1 to 4, from 1 to 4, then again from 4 forward search will be applied. Then if, as I'm saying that forward search will be applied from 4, you can't go to 2. Okay, this is the backward. From 4 you have to go to 8 only. Okay, again from 8 you can't go backward, you have to apply the forward search 9. At the same time, whenever you are applying forward search from 1 to 4, same time, if I'm saying that I have to start from goal node 16, backward search means 16 to 12 it will go, no? Then from 12 at the time 4 to 8, at that time it will go 12 to 10. The time 8 to 9 it will go from 10 to 9, but 10 to 11 this is the forward search. Okay, 10 to 9 this is the backward search. As they intersect in a single point, so we can say that yes, the searching technique is successful and 16 can be my goal node. Okay, clear? Yes or no?
Yes, ma'am. Yes, ma'am.
Okay, so as two types of searching techniques are used, or two types of searches are used, so we can say that the searching is very much fast, and we can search one node within less amount of time as compared to other searching techniques. And disadvantage is its implementation is very much costlier, because we are taking two searching, and one should know the goal state in advance also. Okay, so that is the thing. Next we will go to informed search algorithm. Okay, informed search algorithm. Under informed search algorithm, we have various searching techniques like best first search, A star search, AO star search, problem reduction, hill climbing. Okay, all these things are there. We will discuss one by one. First one is your best first search algorithm. Okay, here why I have written this is basically based upon greedy search. In case of your best first search, wait, I'm saying, okay, let me give you one real life example. In case of your best first search, like the example that I usually give, you are in fire station and you have to go to your destination city. Okay, and you have two ways only, with from fire station Bormunda and city Bormunda, that Tapavana High School road to city, and fire station direct Khandagiri and city. Okay, you have these two paths. Okay, from those two paths you have to choose the best path at that moment. Okay, best path at that moment. You have to calculate that may be in terms of cost, or that may be in terms of time. Let you have to reach within very little time. Okay, so that may if you want to reach in less time, or the cost may be high. Okay, so that depends on person to person. Okay, you have to choose the best path at that moment. Okay, so that is nothing but your greedy search. Greedy search, that means whether you have more than one alternative, you have to choose the best path. Okay, best path means definitely we will opt the path that will cost less. Okay, so here it is the combination of depth first search and breadth first search of your uninformed search. How it acts like that we will discuss later. Okay, it uses the heuristic function that I will tell you. Heuristic value will be given. One heuristic value means the cost. Okay, the cost of the cost of the path. That means from fire station to, suppose from fire. Yes, so suppose from fire station to your Khandagiri, what is the cost? From fire station to Bormunda, what is the cost? Okay, that is we are saying here that heuristic value. Okay, for so, and heuristic value function will be calculated so that it will be calculated such that your h of n should be less than or equal to h star n, where n is your node, h of n is your heuristic cost, h star n is your estimated cost. Heuristic cost will be given, and estimated cost means no doubt the cost of the Bormunda is to reach from fire station to Bormunda. Let the cost is 5 rupees. Okay, and you go in Ola. Okay, you go by Ola late, and the traffic is very much jam, so it depends on time also. And as late to reach from fire station to Bormunda, late for some reason you take 1 hour. Okay, then you 1 hour or half an hour, then you will be you have to give more than that. Suppose normally it takes 5 rupees, then you have to give, definitely you have to pay it's 10 times or 5 times higher than this 5 rupees. Okay, that is the estimated cost. For each node we have to evaluate the estimated cost. Heuristic cost will be given. So and you have to choose the node whose heuristic cost or h of n is less than equals to your estimated cost. Okay, that is the thing. This is the algorithm that you can check it by your own. Let me take one example. This type of question you will be getting in your exam. Okay, so this tree like structure is given where heuristic value is given. Heuristic value is given for each node. Okay, you are suppose this is the root node, its heuristic value is 13. Heuristic value means we can say h of n. Okay, this 13. For a its heuristic value is 12, for b its heuristic value is 4, for c 7, d 3, e 8, f 2, h 4, I 9, and g it's 0. Okay, and as it is one of the searching technique, you will be given initially you will be given the goal node. Okay, goal node. Okay, you have to find the path. What is the path to reach to your goal node? You are in this lesson from S you can reach to G by several. Here no doubt you have a single path S to B. Here I have done the tree where you have only the single path S to B to F to G. Okay, the tree may be there, the tree may be like several paths must be there to reach to any node. You may have more than one path also. Okay, here I have done the tree where you have only a single path, and I have chosen G as the goal node because this example I have given by my own. Okay, so you just check it and you can implement the same concept with other examples. Okay, but heuristic value will be given in the question and goal node will also be given. Okay, and whenever listen this best first search, I have told you this this is one of the greedy search, you can say that, and here you have to choose the best path at that time. Okay, so here to apply the best first search you have to make two lists. One is your open list, another one is your closed list. Okay, first of all in closed listen, you just add your starting symbol or root node. What is your root node? Your root node is S. Okay, here I have added the in closed list. As I have told you, you have two lists: open list, closed list. In closed list initially you add S. S is your starting node from the point you will start your searching process. Okay, so that you add that S in closed list. After that in open list what you have to mention, expand. Next step is expand the node S, and whatever the node present, whatever the child node of S you have, those will be mentioned in open list. Okay, initially S will be there in closed list, and in the closed list whatever you have to expand it. That means you have to look at its child node. Okay, whatever the child node you have, those will be mentioned in open list. So as S is having two child A and B, so A and B will be in open list. That I have written in this algorithm. Place the starting node into open list. Initially it will be open list, and by default from open list it will go to closed list. Okay, remove the node N from the open list which has the lowest value of H of N. You let me explain it first, then by going through those algorithm you can easily get it. Okay, so in closed list you have S, then you have to check what are the child node of S. Those will be mentioned in open list. A and B are child of S, so those are in open list. After that you have to check the heuristic value of A and B. Okay, heuristic value of A and B. Heuristic value of A and B means here it is mentioned heuristic value of A is 12, heuristic value of B is 4. So the node having less heuristic value, that will be added in closed list. Okay, as 12, h of a is 12, h of heuristic value of b is 4. The node having less heuristic value, that is b is having less heuristic value, so b will be added in closed list, and in open list a will be remained. Okay, then I have told you whatever the nodes you have in closed list, that node you have to expand only. Okay, and the moment you find your goal node in the closed list, that moment only you have to stop your searching process. Okay, till that you have to proceed. So till now we haven't found that our goal node G. All of you listening or not? Are you getting whatever I'm saying?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so till now we have S and B in our closed list. We have already expanded S, remaining is B. We have to expand B. That means we have to check what are the successors of B, or what are the child of B. Okay, so B is having two child, E and F. So both E and F will be added in what? Open list. Open list. In open list initially you had A, and E and F will be added. E and F will be added. Okay, after that whatever you have in open list, again you have to check its heuristic value. Heuristic value of A, heuristic value of E, heuristic value of F. We know that heuristic value of A was 12. Heuristic value of E is 8. Heuristic value of F is 2. From 12, 8 and 2, which one is minimum? 2 is minimum. So F will be added in closed list, and in open list A and E will be as it is. Okay, getting?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now in closed list we have S, we have already expanded S, we have already expanded B. Now we have to expand F. Whatever you have in open list, no need to expand them. Okay, whatever you have in closed list, you have to expand them also only. So now we have to expand F. So to expand F, I have to check what are its child node. F its child node is I and G. So I have to I have to add those in open list first. So those I and G, here I have skipped that step. I and G you have to add them first in open list, then again you check, as G is having 0 its heuristic value, so definitely G will be added in closed list. G will be added in closed list. Okay, so after that, as G is my goal node, so no need to again search. Okay, so that this is the path S to B, S, B, F, G. The path to goal node G is S to B, B to F, F to G. Look at here, S to B, B to F, F to G. Okay, whatever you have in open list, you forget it. Okay, the moment you get your goal node in closed list, you stop your searching process there only. Getting?
Yes, ma'am. Yes, ma'am.
All of you clear or not?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, fine. Next one is your A star search algorithm. Best first search we have discussed. A star search algorithm. Let me explain. In A star search algorithm also, after this problem, here I have written the algorithm. You just first let me discuss with you. Let me explain this problem, because in your exam the problem will be given. Okay, if you know how to solve the problem, you can write the algorithm by your own, because algorithm is nothing but your step-by-step instruction to solve the problem. Okay. So in your A star search algorithm, this is the graph. This can be applied in a graph or in a tree also. Let this is given, S is my start node and G is my goal node. Same, what is the path? Listen here. What is the path to reach from starting node to goal node. Listen, here I can say that there is a path S to A to C to G, S to A to B to D to G, or S A C D G, isn't it? Or I can say S A S also I can say. But how the path, like here, let you are in fire station, this is the CET, then fire station Barmunda, Tapabuna High School, or any, suppose Naka Gate, this is CET. Okay, like that many more paths are there, and but we have to choose the best path to reach from S to G. Okay, so how that best path will be calculated? Okay, so here mark here, one path value is given, S to A, the suppose fire station to Barmunda, the cost is 1, Barmunda to Tapabuna High School cost is 2, Tapabuna High School to Nakagate cost is 5, it is cost is 2. Okay, so like that, these are the nodes. This path value is having one, this path is having one cost. Again, with that you have the heuristic value for each node only. Okay, in case of your A star search algorithm, in case of your best first search, for the A star search, the searching technique that we were discussing now, best first search, in that case only we were considering regarding your heuristic value of each node, but in this case we have to take care of the heuristic value of the path and of the node also. Okay, and this heuristic value will be the heuristic value of the node given in your question. So this is given, S is heuristic value is 5, A 3, B 4, C 2, D 6, G 0. Okay, your step 1 says you have to start always from your start node S. Yes, your S is having two roots or not, S to A and S to G. S to A and S to G. S is having two successors, A and G. Okay, for each path you have to calculate the heuristic function. Okay, heuristic function, that function is S to, suppose for S to A, the heuristic function is f of n equals to g of n plus h of n, where g of n is the path value means S to A its path value, and h of n is heuristic value of destination node. Destination node means you are going from S to A, so start node is S, destination node is A, heuristic value of A. Okay, so S to A, its heuristic function will be path value is 1, and heuristic value of A is 3. So S to A, the heuristic function will be 4. Same as from S to successors are there, so S to G also we have to find the heuristic function. So same, g of n plus h of n. G of n is the path value from S to G, and h of n is the heuristic value of destination node. So path value is S to G 10, and heuristic value of destination node G is having its heuristic value as 0. So 10 plus 0, 10. After that, from S to A and S to G, you have to check which one is the minimum value. Okay, as 4 is the minimum value. So yes, as 4 is the minimum value, so we can say that this is the best path. Okay, and the value which is higher, that you have to keep it in holding position. Just you hold it. Okay, later we will decide whether that will be the best path or not. Okay, so till now we found that S to A is the best path 4. Now from A, as we have chosen S to A is the best path, now I have to check what are the paths from, what are the successors from A. Okay, so from A again we have two routes, A to B and A to C. So we have two paths, S to A to B, S to A to C. S to A to B, what will be the heuristic function? Heuristic function is calculated as the path value plus heuristic value of the destination node. So S to A to B, if the path value is 1 plus 2, and heuristic value of the destination node is B here. So therefore, so 1 plus 2 plus 4, mark here 1 plus 2 plus 4, okay, that is 7, and another one root was S2A to C. So S2A to C, mark here S2A to C, the path value was 1 plus 1 and the heuristic value of the destination node is C, its heuristic value is 2. So 1 plus 1 plus 2 value is 4. So from 7 and 4, the path having lowest heuristic function, that will be taken into consideration. So now for till now we found the path as S to S to C, and that 7 again we put it in hold position. Okay, again you hold it. Okay, till now you got the path S to A to C as base path. Okay, again from C you have two alternatives, C to D, C to G. Okay, again you have to S to A to C to D, S to A to C to G. Okay, same you have to calculate S to A to C to D. For that 1 plus 1 plus 3 plus heuristic value of D is 6, same 1 plus 1 plus 3 plus 6, heuristic value of D is 6, so result was 11. And S to A to C to G, heuristic value is calculated as 1 plus 1 plus 4 plus heuristic value of G is 0, so result is 6. From this 11 and 6, as 6 is having the lowest value, so and here our goal node is 0, and we have already reached to our goal node, so we can say that this is the best path, S to A to C to G. Till now we know that this is the best path, and also before that we have put various values in hold. We have hold these values, okay, 10 and 7 and 11. Okay, so we have to neglect, we have to calculate or estimate something, and we have to ignore or remove those values. Okay, so the moment you get your goal node, okay, that is definitely the best path. So here I have found that S to A to C to G, that is the best path. Okay, after that here its value is 6. Okay, so first on this value S to G 10, which was in holding position, so check 10 is less than 6 or greater than 6. As it is greater than 6, so neglect it. Okay, this is the first hold value. Then we found the second hold value was 7. Again 7 is greater than 6, so neglect it. If any value will be less than 6, then immediately we could say that from node state, immediately we could suppose this is the 5. Okay, 5 less than 6, so again we have to go which path was that where we found that value 5, and we made it as we put that 5 as in holding position. Okay, and we had to choose that path only. Suppose S to G is a direct path whose value was 5, and we have put that value in holding position. So in that case we had to consider that value. As here 7 is greater than 6, so neglect this value. And next one is we found 11 greater than 6, so neglect that value. Okay, next so we can say that the final path is S to A to C to G. Clear? And the cost to reach from your starting node to your goal node is 6. Clear? Are you clear or not?
Yes, ma'am. Yes, ma'am.
मैम
Yes.
मैम जदि हमरा गोटे वैल्यूटा लेस देन 6 तो हमें
सेमती तो हे ही पारि न थांदा, सेठी तो हमें कंसीडर कर दै थांते ना. जदि सेमती जदि हेई थांदा, सपोज 8 लेस देन 6 आसीबो माने तमे तो सेटा को फर्स्ट ऑफ ऑल तमरो कोन माने पाथ रे नै सारी थिबो ना. सपोज ए केस रे मोर 6 आसी थिले, सपोज लेस देन 6 आसी थांता, हाँ देखो देखो सपोज एटी मोर 5 इन प्लेस ऑफ दिस 10 सपोज एटी 5 आसी थांता हैला तो एटी तो मु 4 को कंसीडर करि सारी छी बुझि पारुछ तो तमरो एटी 5 लेस देन 6 5 लेस देन 6 माने मोर एटी पाथटा कोन आसी छी S टू G आसी छी तो डेफिनेटली मु कोन करबी तो मोर इनिशियली मु जते बेले S टू A टू C टू G जाउथिली सेते बेले कॉस्ट थिला 6 बट एटी मु जते बेले कोन कंसीडर कली 5 लेस देन 6 तो मु डायरेक्ट मु एटी मोर गोल नोड को पहुंच जाउ छी ना S टू G सो मु एई पाथटा को नै थांती बुझि पालो
Yes, ma'am.
एनी डाउट any doubt
No, ma'am. No, ma'am.
okay next class we will discuss regarding AO star search algorithm and hill climbing method okay
Yes, ma'am.
tomorrow
Yes,
we
ma'am.
will discuss okay okay thank you
Thank you, ma'am. Thank you, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you.